Okay, so I started the recording and then I will hand over ownership to you. Make you the host. There you go. You should be host. And just like last time, when you're done, go ahead and just close the meeting and it should automatically capture the recording.
Righty. Okay, is everybody able to see my screen and hear me? Okay then. How many we got? 25. We'll give people a minute or two.
Another few minutes. Yeah. Give them a chance to get here. There we go now. I've got about 40 showing up. I think that's pretty good turnout. You can go ahead and start.
That's an excellent idea. I was muted because I have the mute button up here. Yeah, let's go ahead and start. Today, we're going to be talking about input and output. Last time, we messed around a little bit with input and output, but we've been messing around with output the whole time. It's kind of a challenge to not mess around with output. So let's do some stuff with the input function. So here we have some examples of using it. As I said, useful programs take input and generate output. So here we practice capturing input from the keyboard. You can take input from a variety of sources. Pretty much any stream that the computer has access to. What do I mean by a stream? Well, keyboard, that's one. As I'm moving my mouse around the direction I move the mouse per frame, that's another one. A button on the mouse, that's another one. I could take a file location. I could take a website URL. Input can come from a lot of places, but for the most part, we're going to be, at least for today, I think later we're going to be doing files, but today we're going to be taking input from the keyboard. So here's an example. I got a variable here. It's called fries. And I'm going to take input. What does input do? Prompts the user to enter a value. Okay. And then I'm going to print the type of the variable after I've taken the input and put it in there. And then I'm going to print the value of that variable. So what should I put here? So it's not telling me anything interesting. So I'll just say hello. All right. I have data type string and value of HELLO, just as I entered it. Try it again, see if what happens when I put in a float.
That's perfect. That's all I wanted.
Well, it's still a string. The values, the characters 3, period, 0. We kind of looked at this last time. It's kind of strange that 3.0 is a string. We'll get into why that is here in a second. We can also do a cast on our input. So let's do the same thing we just did before. But as I'm taking my input, I'm going to cast it into a string. All right, so what did I say first? Hello. All right. It is type string, value, hello, just like we had before. And if I do 3.0, just like we had before. Let's see if we can do something different. I think I can do this. Well, when I print, well, it's not when I print it. It's just the print the type and then print true. Okay. All right. So the value of true is a Boolean. It has to be capitalized first. As you see, once it's green. Well, what I'm going to try to do here is I'm going to try and take an input and cast it into a Boolean, see if it works. Well, first I'm going to do the hello. It casts it into a Boolean, and the data type is true. Interesting. Wonder why it would do that. What about 3.0? Same thing. What if I do false? Still true. What if I do FALSE just like that? True. So as I'm trying to cast this into a Boolean, it's taking my string and whatever method it's using to cast it from either true or false, it's always going to true. So let's try something else. I know this one will work. All right, let's try inputting something that will cast a float. Hello. Well, now we have a problem. I can't convert string to float. All right, well, let's try a string that looks like that. So it appears that when I take input, that can possibly be a float, has no problem with it. All right, let's mess around with the string thing some more. So we're going to do the same thing we had before. We're going to take input, we're going to cast it into a string, but then we're going to do something a little different. I'm going to use the upper method. So this syntax here. All right. This syntax here is what's known as a method. So fries is a variable, and we know it's a string variable. And there's a method on string that it's called upper, and what it does is it changes all the characters to uppercase. So let's mess with that and see what it does. All right, so take some input, hello, and I get back all caps. It's cruise control. Cruise control for cool. Now, as you see, I have some uppercase letters in here. Let's see what happens when they get uppercased. Well, they don't change. What happens when I do 3.0? Not a lot. There's no uppercase version of 3. All right. What else can we do? Can anybody tell me? So this is the method to take a string and for every character in it, make it uppercase. Can anybody tell me the method to take a string and for every character make it lowercase? dot lower. Let's try that. All right. I'll take this. Yep. Converts it to lower. Interesting. All right. Anybody have any questions or isn't following about just the basic taking input and bringing it back out and storing in the variable? Okay. It is worth noting. So I'll take this time to point out one, unless it's extremely, there's a very good reason. It's generally not a good idea to direct message me, because then I just have to read out what you say and decide if it's supposed to be read out or not. And secondly, so when I say it, does anybody have any questions on something? It's generally a good idea to actually type out the question. So what's your issue? What's on your mind? And while he types it out, I'll point out that there were two responses for casting something, or not casting, the lower method. One person said lower, just like this, and one person said lower, just like this. Now, granted, I had the upper letters highlighted, but what happens if I try to do this without the parentheses? Let's see, H-E-L-L-O. Interesting. I have a class of a built-in function or method, and the data value is some weird gobbledygook. So what's that about? Okay, so James asks, so what is this? Well, it is kind of like if I were to print is all right, x equals 3, right? I've got a variable x, I'm going to set it to 3. Okay, so I'm going to print out is x equal to 3. The answer is true. Well, what happens if I try to print out x equals 3? Now, Python won't let me do it, but what's happening here is I'm trying to print the result of an assignment. So when I say assign 3 into x, it goes, okay. And then I say, now print that. Print what? Print the assignment. Kind of doesn't understand what to do. Same thing's going on here. When I call this method, it does what the method is supposed to do. When I give it the actual method itself, it's saying, yeah, you gave me a method. You're not using it. You're just pointing at it. Okay. Now, James asks, what is the use of the first and second line in cell 16? Cell 16. The number on the left is not a numbering of the cells. It is a numbering of execution. So if I run this again, it'll now be 20. So this one here, okay, I'll ask again, please, when you're asking questions, unless it is for some very good reason, please ask it to everybody. Please don't direct message me, because now I have to read it out and give this message and blah, 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 blah. Okay, so first and second lines in this one, well, it's the same thing we've been looking at. The first one is the input function that takes input, stores it in a variable. The second one is a typecasting. We're taking the variable fries and whatever is in there, we're going to force it to be a string. All right, so Ben says, keep saying cell not executed due to pending input. I'm pretty sure I know what that is. And this one will trip you up quite a few times. Well, all right, I ran my code here and then I forgot what I was doing. So I'm going to go down here. Well, that didn't work. I'll go down here. Well, that didn't work. It's because I haven't given input here. I haven't completed what's going on. So once I do that, actually, the funny thing is, because I did that and tried to execute all this stuff, weird stuff's happening. As you can see, my kernel's busy. So what we should do, stop your kernel, restart it, and then make sure when you run something that takes input, you either give it input and let it finish what it's doing, or you terminate the process. Now, in order to do that, you're going to have to hit the stop button. Interrupted by user, just like that. Okay. Yeah. All right. Let's move on to the exercise. So let's take case 3, and instead of casting it to a string, let's make it into something numeric. And then run the script to validate the modification. All right. So I have a variable taking input. I'm going to cast it to a string. I'm going to make it uppercase, and then I'm going to make it into an integer. All right, well, let's see what happens. I'm going to take 3 point, oh, let's just say 3. I know 3 should work. All right. I'm casting it to an int. Works just fine. What happens if I do 3 point? Kind of a problem. It is not able to cast this variable, well, this value 3.0 into an integer. What if I do that? It's not liking that either. What about low? It's not liking that either. So what is going on here is that the function that can cast something into an integer really only works on stuff that can possibly be an integer. I think we went over this in lab 2. I can change this to float if I like. And we'll work on that now. If I put something in that doesn't have an obvious float, it's going to have a problem. I can't think of anything else interesting to do with this, because really the data types we're going to be messing with are string, float, and integer, and we just did all of them. I could do some other stuff, but it's not really worth it. All right. It's a good idea to tell the user what to input. You can do this by putting the hint in quotes inside the input parentheses. The hint will come in the next line and will wait for the user input. You can then type the input, and when you hit the enter key, it'll capture the input. In this example, tell me a beautiful number is the hint. This gets printed in the next line when asking for the input. If you type 6, this will be assigned into the variable beautiful number, which we can print later. All right. So the only difference here is instead of just having a blank line that takes input, now we have a prompt. It says, tell me a beautiful number. So, okay, put 6 in there. All right, cool. Prints out 6. Why does it print out 6? Because it prints out the value of our variable. Let's try what we were doing earlier. Okay, we walk up to the kiosk and it says, would you like fries with that? Enter Y or N. And I don't want fries because I'm trying to watch my carbs. So I do that. And it's like, all right, cool. What if I'm being belligerent and I say, I'm not even don't have to be belligerent. I just say, instead of Y or N, I say, no, thank you. Well, this isn't a very smart program. It doesn't actually even do anything. It just takes what I tell it and prints right back out. Just like we had before, we're going to cast everything into uppercase. So now we're kind of trying to handle what if the user enters lowercase y? Well, we're trying to get an uppercase y. Well, we could deal with that. I can just make it uppercase. The prompt could be any string variable, meaning I don't have to type out the actual prompt I want. I could store that into a variable. That way it's a lot of benefits. So I could take the variable of whatever I want to prompt. I can put it into the input function, and this functions just like this one here. It's a little hard to see because it's zoomed out a little bit, but this is a scene from the Terminator. And if you haven't seen the Terminator, you should. It's great. So another thing we can do, the prompt can be drawn from a list of prompts, like in the Cyberdyne 101 shown above. wonder if I can show this. Nope, it's gone private. In this scene, the machine is, the door is knocked on and asks what's going on. And so we see from the machine's vision a list of things that could be used as appropriate responses. So they say, like, you better open the door. And so here's my responses. Or what? Go away. Please come back later. And then some more colorful language here that's kind of blurred out. So we can do that too. So I've got a list. I got a list of strings. And that list is yes, no, or what, go away, please come back later, and then some placeholders. And then what I'm going to do is say, take input, and the prompt I'm going to give the user is the element at position 4. Now, can anybody tell me what the element at position 4 in this list is? It's pretty rude, Hunter, to tell me to go away. But all right. So DJ, the classic attempt at a solution for problems like that is restart the kernel. Just like with everything, unplug it, plug it back in. Yeah, anyway. So is it go away or is it please come back later? I don't know. Let's find out. Well, remember in Python, we count from 0. So this is 0. This is 1. This is 2. This is 3. And this is 4. So it is please come back later. But I totally understand why you would say this. It takes a long time to get used to. And even then, you'll still mess it up forever and ever. Okay, so let's run it. Please come back later is the prompt. It is the position 4 part of our list. Please come back later. No. Yeah, so what Dr. Cleveland just said is some attempts at a solution. I will tell you now, this happens to me and it happens to students all the time for the rest of the course. When we're dealing with input, invariably something's gonna go along like, do I want fries? Yeah, fries, please. Fries, please. Cool. So I don't know. I hit the, instead of hitting the enter button, I hit the backslash. All right, fine, whatever. And now I move on. I'm gonna move on. I can't move on because the kernel is stuck here. It's waiting for input. It is paused. It will not go any further until it gets input. So I'm gonna give it some input. And I'm a little surprised it worked that way. Now that I actually finished this one, when I ran something down here, well, now we're running into, well, what's running and what's not. So make sure when you, that's weird. Make sure when you are running a script with input that you finish it, stop it, or interrupt it, which is kind of the same as stop. Okay. So let's do this exercise. Run the script below a few times. It should output a randomly selected integer from 0 to 6. Then copy the Cyberdyne prompt list above to the location shown. Replace the last 2 placeholder strings with the responses from the movie in the image above. Then run the script 6 times. How many times does the Terminator respond with your replacements for the placeholders? Huh. All right, well, let's run. We get a 5. This is like rolling a die. Got a 5 again. And a 0. A 4, and a 4, and a 4, and a 3, and a 2. And now I can, and I will. This is something we're going to be doing later. What's the likelihood of getting a 4? What's the likelihood of getting a 6? What's going on here? Is this really random? Well, how about I run it 100 times? And then I print out how many times I got a 0, and a 1, and a 2, and a 3, and a 4, and a 5. Well, that is getting into some statistical stuff, like the mean of what's going on. So that's something later we're going to do in a later lab. Okay, we ran it a couple times. Let's copy the Cyberdyne prompt right here. Print prompt element as determined by the random choice. Okay, print prompt. What should I put here? What is the index I should be looking for? Should I put, so I got a 4 last time. Should I put a 4 there? What goes here? What should I put? So my prompt. Why do we want to put this? Correct, but why would I want to put that? It's not a number. It's kind of weird. It's because it's our variable. And what kind of thing is this variable going to be? It's going to be anything from 0 to 5. Actually, I think it actually goes all the way to 6. 0, 1, 2, 3, 4, 5, 6. Yeah, it goes all the way to 6. Someone says low. My prompt will not just always be low. It will be randomly anything from 0 to 6. Yes, it takes the random number result. Okay, so we need to replace our placeholders, and our image here kind of has them blended out because it's a little colorful language. So what's some other, anybody know some other lines from the Terminator? I'll accept Terminator 2 lines, but nothing else. None of that other new garbage. Dark Fate, more like garbage. I'd be back. Yeah, we can do that. That's one, and then the next one. Yeah, that'll work. I was expecting hasta la vista, but that works too. All right, let's try. Please come back later. We got no. Please come back later. No. Or what? Please come back later. Go away. I'd be back. Yep. Works just fine. Okay. Let's put some of that knowledge into something a little more useful. Suppose we're building an automated food service program. If you call from your life, that when you complete your order, the cashier always asks, would you like fries with that? Well, let's script this interaction to try to get yes or no. So just like we had before, I have a list of statements here. First one's thank you for your order. Second one, would you like fries with that? Excellent, I'll add them to your order. Have a nice day. Are you sure? They're really good. Okay, no fries. And then we have you didn't enter yes or no. I can't take this ambiguity. So this is the prompt in general. This is the prompt to ask for fries. This is in case they say yes. This is in case they say no. We're going to be really pushy. We're going to say, they said no, try to do it again. If they say no twice, well, all right. And if they give you anything else, here's the message for to give them. All right, so what am I going to do? I'm going to print the first element of statements, and that's here. Oops, right there. Then I'm going to take some input. Now, what's going on here? There's a whole bunch of stuff. Well, it's just like we were doing above, where we take some input, which is string, and make it uppercase, except I'm going to smush it all into one line, and it runs from the inside out. So inputs, statement 1 is the first thing to happen. It's going to print this. And then from there, it's going to move on to what is next. And what is next is to cast it to a string. And then what's after that, to go uppercase. And then we're going to get into some conditionals. Let's see what happens. All right. Would you like fries with that too? No, I don't want carbs. Are you sure? They're really yummy. And I said no. Okay. Now notice it's asking for a uppercase Y or an uppercase N. And I give a lowercase. We're casting it to upper. Well, not saying not casting. I keep saying that. We're making everything uppercase, so that's totally fine. What's some other things? If I say yes, all right, I'll add them to your order. What if I say, would you like fries with that? And I say no. The program can't handle anything other than a Y or an N. So people are saying they don't seem to be getting 6. Well, let's do something interesting. I'm going to make a loop. And what's this loop going to do? For I in, I think this will work. Let's find out. Print 0, 6. All right, well, let's do it the easy way. 0, 1, 2, 3, 4, 5, 6. All right, we've got a list from 1 to 6 or 0 to 6. And what I'm going to do? Wait, what am I doing? Let's do this instead. X equals 0. Okay. While x less than 100, do the following. Add 1 to x. And do this. This is going to give me a whole bunch of numbers. And I'm going to print it. Yep. All right. Okay. See a whole bunch of zeros, see a whole bunch of ones. I don't see a 6 anywhere. Can anybody? Well, but here's the thing. It's possible there's a 6 in here. Don't know. I'd have to go through them all. Especially if I make this something large. Needs to be from 0 to 7. Interesting. Maybe. How do we test that hypothesis? Can anybody give me print that I found a 6 if? Okay, I want to print a message to the screen. Okay, you say break the loop, it becomes 6. That would work. That would also work. But let's try to do it this way. Can anybody give me a, how would I do this? How do I print to the screen that, hey, I found a 6, so everything's fine? What do I put here? Control F. Let me be a little more specific. How do I write some code that does that? Yes. So if I prompt the 6, then print found a 6. Now, what Parth was suggesting, if once I find a 6, I don't care if there's any more 6s. All I know is 1. So if this were some huge ridiculous number, what I can do is, I don't need that, is I say to the loop, in fact, if I were to just make this an infinite loop, I say once you find a 6, break. And what break does is it breaks out a loop. All right, let's see. Do we ever find a 6? Ironically, no, we don't. Now, if I change this to a 7, hey, I found a 6. Okay. Let's see. So back to where we were. In these examples, we don't operate on the input much. However, let's conclude the beautiful number example, do something with it. All right, we're going to take input, cast it to a float, and then do something strange. What's all this? What this percent per 3? That's weird. That's weird. Someone give me a beautiful number. 42. That's a good one. The beautiful number 42.0 squared is 1764. Cool. What if I try to do this? Can I have a problem? All right. How could you approximate the square root using just the tool above? And I'm not going to mess this up this time. So everybody should know what the square root is. If I have a and b, well, if I have a and I multiply it by a, I get a squared. What's the square root of a squared? It's a. So using just your knowledge of square root and what we have here, can someone tell me, probably go, bit by bit, what we're going to do to approximate this to the square root of our stuff here? Now, as I suggest, we should probably do this in English first. So what's the first thing we want to do? Input the number. Very good. Take number as input. All right, what do we do once we got the number? Find the square root. Yep, got it. Find square root. Done. So let's be a little more specific. When I say find the square root, how do I do that? What am I need to do? Interesting. Now, I'm going to pretend I didn't see that. You weren't supposed to do that. When I say using just the tool above, we need to try to use the code we have here. What you did is exactly what I did last semester. And yeah, you're correct. Let's try using what's going on here. No, we're not going to input and use the math module. We're just going to use what we have up here. So let's start. My number is this. Kapow. Okay. What can I use from above? Let's take 100. Print number 100. What can I use from above to okay, so let's ask, what's the square root of 100? Almost said it. $10. That's correct. So how there's something I should point out here. We are approximating the square root of something. Now, approximating the square root seems kind of silly. Why do I need to approximate the square root? It's easy. 100 is 10 times 10. Everybody knows that. Well, what about 204,490? What's the square root of that? Anybody tell me off the top of their head? $14-ish? Nah, interesting. Wait, is that a decimal? Okay, yeah, it's like 204. Yep, we got some smart cookies here. So Jackson, you're correct. That's exactly what we're doing. The thing is, we have to list out the instructions that do that. And we can do a little better than just doing the first 50. We can do a little better than that. But yes, that's what we want to do. Now, what Parth said is very interesting. I asked, what's the square root of 204.49? To which Parth said 14-ish. Now, what made you say 14-ish? It's close to 196. And what is 196? You're doing a process in your head. And yes, it's the square of 14. And now the process you're doing is, well, is 204. Well, here's what you're doing. I'm going to take 1 times 1. Well, actually, I'm going to take x times x, where x is, well, what am I doing? I already have the variable. I'm going to take the number times the number, and I'm going to run with it and see what it is. All right, what's 1? Oops. I got to cast it float first. All right, what's 1? What's going on here? Couldn't. Oh, yeah, it's my variable above. Haha. All right, what's the square root of 1? It's 1. What's the square root of 2? It is 4. What's the square root of 3? It's 9. What's the square root of 70? 4,900. I went too far. So the process you're going through is you're going to keep incrementing the square root until you pass 204. Now, let's play this game. Let's see. Let's play the game of let's mess with 204. Somebody tell me. I'm going to start with 1. Seems fair. 1 was too low. What's a good guess to try next for 204? Trying to figure out what the square root of 204 is. What should I enter as input to my little x times x? And no one say 14. Two. Very good. That's perfectly fine. 2, it's 4. So we're going up by 1. That's fine. Another interesting thing would to try to go, all right, I'm going to go something small, something huge, and then maybe try to cut the middle, but this is totally fine. So 2, it's too small. 3, it's too small. 4, it's too small. Let's keep going. 5, 6. Now I'm going to get all the way to 13 because somebody has already kind of guessed it. 13 is 169. Okay. What's 14? It's 196. Getting close. What's 15? 225. So that means when I get the 14 times 14, it's below this number. And when I get 15 times 15, it's above this number. So if I could automate trying to do what I just did, then it would be able to tell me it's between 14 and 15. Now, given the process we just did, how is this program going to tell us the square root of these? Well, for 100, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's going to actually get 100. And it'll say, yep, found it. It's 10. For 4, it'll be 2. For 2, well, that's interesting. What is the square root of 2? Okay. I'm running a little bit out of time. So I think it's a little more important I get to the output, and I'll come back to this in a second. All right. So we've already messed with output quite a lot. You can either output just a raw string, a variable that's a string, a whole bunch of other stuff, just like this. What is your name? Potato. Hello, potato. All right. We can also output values from a list, just like we did before. So my prompt, element 0, 1, 2, 3, print those out. Or we can have a numeric list. Now, what is this? What's going on here? Remember from last time, when I have a colon with nothing on each side, that means I want everything. So this is saying, get everything from number list and print out the type. All right, so print out the list itself. It's like this. And now print out the type, this type list. What happens if I take this away? It gives us the same thing. Interesting. We can print a blank line by using the symbol for new line, which is \n. And remember last time I mentioned the idea of an escape character. To the computer, this is one character, even though I have to move through it with 2 keystrokes. To the computer, this is one character. All right, let's look at an example. Let's build a script that asks the users a name, says hello, skips 8 lines, and identify ourselves as the Terminator model. here's basically the scaffolding of what we want to do. So let's prompt for a name. Anybody know how to ask the user for, well, I guess it's already kind of listed here. We'll take the input, put it into a variable, and print it out. All right. What's your name? Yep. Okay. Says hello. Now let's make it print some line feeds. What's a line feed? It's a blank line. So I'm going to put in \n 8 times. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 9. Okay. What is your name? Yep. And then we have a whole bunch of line feeds. And now we add our response. What's our response? What is your name? It is, my name is Bender. I am a Cyberdyne Terminator Model 101 disguised as a bending robot. My favorite beverage is Albie Bach. Have you seen any living humans around here? Death to all humans. Okay, we can do better. We can format the output. How do we format the output? Well, we use this %sign operator. What this does is it lets us format the output using some built-in things. So here's something we can do. I'm going to put %s right here. What's %s? I don't know. Let's see what happens when I run it. So it should come right after hello. Comes right here. So instead of just saying an uninteractive string, it actually inserted my name into the string itself. And notice it didn't even use the variable to put right here. So what's going on? Well, as you can see, the name variable is being used right here. And what's going on is this is saying everything in here is a string, except for these new lines. And what's right here? And what's right here? Well, it's going to be a variable. What kind of variable is it going to be? It's going to be a string. That's what the S is for. If I were to change this to a D, well, let's see what happens. Oops. It's busy. D is for double. F, I believe, is for float. It's going to have a problem converting my name into a float. What if my name was 3.0? It's also kind of being a problem. Let's try that one. Also not liking it. When you're messing with strings, you want the %s because what is that for? It's for strings. Okay, so the rest of the program, we want to say, so name, tell me a beautiful number. We're going to take a number, cast it to a float. And as I was saying, we got this %sign again. What's this %sign for? Well, in this case, we want to make a float. All right, so let's try it again. Give it my name. Tell me a beautiful number. Somebody give me a beautiful number, 2. Someone earlier said 7. All right, I'll give it 7. The beautiful number 7 squared is 49.000. Interesting. Very interesting. Why is it giving me 7.000 instead of 7.0? If I were to say print this, print my number. 7. My usual print statement says 7.0. So someone says, because you told the float to give 3 decimal places. I did? Where? Yes, that's correct. When I say I want, here's how the sentence goes. This is just raw text. And then computer, here's what I want you to do. You're going to get a float. And I want you to take that float out to 3 decimal places. So as someone said earlier, what we can do is we can take a number and we can use the power operator and the 1/2. I think I need to do this to approximate the square root. Now, the reason I'm doing this is just to show off some decimal stuff. In fact, I'm going to make this, I don't know, 3, just because I can. All right. 2 1/3. All right. Oh, it's busy. What are you not liking? Oh, I don't have enough parentheses. Tell me your number. So 7. When I try to take the 1/3 root of 7, I get 1.913. It's not terribly important that we know the 1/3 root, but what is important is this. What if I wanted more decimal places? Well, I can do that. If I wanted 5. And then 7. I can get as many decimal places as I want, more or less. So that's what's going on here when we're formatting the output. Last thing to mention is the way to end a line when you're printing. Just as I can say, welcome to, I have a variable, the jungle. I can put a variable, just like I always do, var. Well, there's a special part of print, and it's called end, E-N-D. End is what I end the string with. So in this case, I say, welcome to the jungle, and there's nothing there. And here I say Bender's world, the jungle again, and then an exclamation point. Because the end of the line, now here I'll actually make the end of the line just \n. I can do that too. All right. So the homework is just going to be messing with some input and some output. You've got a scaffolding of what you need to do here. Eventually, what we're going to do is we're going to write a program to explore the matrix above for treasure. But first, let's understand the structure. Each cell contains an integer between 1, 1 and 5, 5. For each value, the tens digit represents the row number, and the units digit represents the column number. So this is row 4, column 2. What that means is, if I'm in this spot here, the 4, 2 tells me the next place to go. Row 4, column 2. Now go to row 1, column 5, so on and so forth. The treasure is a cell whose value is the same as its coordinates. So if this value right here were to say 1, 1, it would say go to 1, 1. What that means is that that's where the treasure is. So eventually what we want the program to do is I'm going to give it a start position, and it's going to run, and it's going to go through and say, yep, found the treasure, or nope, couldn't find the treasure. But that's something we'll get to eventually. What we're going to be doing right now, this makes the map. And here's what you guys have to actually do. Write a script to take input from the user in terms of row and column. Return the contents of the treasure map at that position, and that's it. So let's say row 1, column 3. What's the value for that? Row 1, column 3, 3, 2. Indeed, that is what is printed out. Okay, so you need to be able to write a script that instead of, this is what's called hard coding, you need to be able to take input. Now, how you take input for 2 things, it's up to you. You could do it in 1 line, you could do it in 2. All right, so that is input and output. Anybody have any questions or comments, concerns, or I'm always accepting good math jokes? What about the square root question? I ran out of time, but here's what I'll do. I'll stop the recording and then I'll talk about it. I mean, I suppose I can talk about it without stopping the recording. It doesn't hurt. Square root. Where is it? Blinking. About to bust out the Control F. That is why, is because the markdown code got double clicked, as I tend to do. All right, so we were in the process of here of taking an interval, and for us it's 1. And here's the thing. Do you guys have loops? I don't believe you do. I don't think we talked about loops. But we did talk about conditionals. So we can do that. We can make this work. We can make this work. So here's what I'm gonna do. What we were doing, just enter 14.5. 14.5 to 10.25. And the interesting thing about that is you have 14 was 196, 15, which is 225, and then you have 14.5, which is closer. So what Dr. Cleveland's talking about is the method. It's called a binary search that I was trying to get to, but one, I kind of ran out of time, and two, I don't know if you guys have loops yet. So I took 14, oops, and that was too low. I took 15, that's too high. I took 14.5, and that gave me to 10.25. Now here's the thing, do I want to go to the left? I see. I see. I suppose this one always throws me for a loop. Same thing happened last time. I'll do better this afternoon, but the key word is how could you approximate, not how could you write a script to approximate. Yep, that's what I missed. What does any of the things I just said mean? We're supposed to sit here and do the thing, like hit go, and actually do the thing I was just talking about. So 1, and we get to 14, too low, get to 15, 225, too high, 14.5. Too high. All right, somebody give me the next one. What should I try? 14.2. Let's try it. 14.2. 201.64. Too low. So we went from 14.5, which is too high, to 201.64. Too low. All right. So someone give me the next one. What should we try? 14.25. Sure, we can do that. 14.25. 203.062. 625. That is too low. Someone give me a next one. 14.28. We can do that. 14.28. 203.9184. That is too low. It's also not quite as much of a jump as I would have liked. So let's try another one. What? 14.33. All right, let's try that. 14.33. 205.34. Too high. 205.35. Okay, so let's go down a bit. Someone says 14.288. 204.16. That's pretty good. So instead of just keeping right here, let's just keep going. 14.289. So somebody tell me, how close do you want to get before we say we're good? 29. It's pretty close. 14.292. Pretty close. You say right about now is good? Okay, I can dig that. This is the idea of approximating, is I'm going to keep going and going and going and going and going until I reach my quote unquote close enough. Now I'll tell you, this one right here doesn't have an answer, at least not one that I can write down. So the only way to get the square root of 2 is to approximate it. And how do we approximate it? Well, usually you say out to how many digits. All right, so I'm actually not that far over. But yeah, that is that. So any questions on homework? Is the task clear on what needs to be done here? You've been given code. It's actually all over the place. You've been given code to say for a row and a column, print out the value. Your job is to make a script like our Terminator model to prompt the user for a row and a column. Right. When we get loops, we can automate the approximation. Now, the reason this is so darn difficult for me is because just like last time, we were writing a function without talking about functions. It's like trying to describe an elephant without using the word elephant. Here, it's very difficult for me to talk about this without thinking in a loop, because what does my brain go immediately to? Okay, make a loop. And while you are under, keep going until you go over, and then immediately take the under and the over and start cutting it in half. That's called a binary approximation. It's immediately what my brain goes to. And it's very hard for me not to think about it. Bisection, yes, yes. Okay, I don't see any questions on the homework. I expect to get them in email. I'm grading, so assignments will be graded. I'm gonna hate myself for setting this up, but assignments will be graded within a week. So all your Wednesday homework will be graded before Wednesday lab. All right, I expect to get a bunch of questions about this because it's input on two things. Now, how am I going to take input on two things? I don't know. Well, I do know, but you know what I mean. All right, didn't get any questions and everybody's gone. So I'm going to end the recording and get back to grading. So I will see you all on Wednesday. Thank you.